The vertical jungle, how trees created an entire world. 150 feet above the forest floor, in near total darkness, something is happening that most humans will never witness. A sloth is giving birth. She hangs upside down from a branch thicker than your leg, moving so slowly that algae grows in her fur. Around her exists an entire airborne ecosystem. Insects that never touch the ground. Frogs breeding in rainwater trapped high in the branches. Orchids rooted to bark. Snakes hunting where a single mistake means a fatal fall. This suspended world supports more species than most countries. It shouldn't exist. There's no soil. Water must be captured from rain and mist. Gravity punishes everything. And yet, this ecosystem doesn't just survive, it thrives. Rainforest canopies alone contain roughly half of all species on Earth. Most people think a forest is the trees. But the trees are only the structure. The real story is what lies between them. In the branches. In the gaps. In the layers of life stacked vertically like floors in a skyscraper. This film isn't about scenic jungle shots. It's about the most complex three-dimensional ecosystem on the planet, built by organisms that can't move, locked in competition for a single resource, light. If you enjoy deep, slow science stories like this, liking the video helps more people find them. Today, we'll climb the rainforest from bottom to top. From the decomposing basement where nothing ever dries, to the understory that survives on scraps of sunlight, to the canopy where most life unfolds, and finally to the emergent giant standing alone against the sky. This is the vertical jungle. And it's stranger than you think. The foundation, forest floor. Let's start at the bottom, the place most documentaries barely pause. The forest floor isn't shaded. It's dark. In a mature rainforest, less than 2% of sunlight reaches the ground. Light is filtered and scattered dozens of times before it ever touches soil. What arrives is weak. Diffuse. Green-tinted from passing through millions of leaves. And yet, this darkness is alive. The soil here is shockingly thin. In many rainforests, the nutrient-rich layer is only a few inches deep. Beneath it lies clay, sand, laterite, earth so poor it struggles to support crops once the forest is cleared. So where do the nutrients live? Not on the ground. They live in motion. A rainforest stores its nutrients inside living bodies, trees, fungi, insects, cycling them rapidly, relentlessly. When a leaf falls, its journey is brief. Within hours, fungi arrive. Bacteria follow. Termites and beetles reduce it to fragments. Nutrients are pulled back into roots almost immediately. The forest floor is a recycling system that never stops. It's also crowded with life most people never notice. Leafcutter ants marching in lines hundreds of feet long. Army ants sweep through in living waves. Bullet ants deliver one of the most painful stings on Earth. Millipedes the length of your hand. Velvet worms firing glue to trap prey. Beetles farming mold inside rotting logs. This layer doesn't look impressive. But without it, everything above would fail. No decomposition means no nutrients. No nutrients mean starving trees. The canopy thins. The forest collapses. The floor is dark, wet, and claustrophobic. And it is the engine of the entire system. The understory, survival in shadows. Now we climb. 10 feet. 20. 30. Welcome to the understory, the middle layer, where survival is measured in patience. Light here is scarce. Trees grow slowly, often spending decades waiting for a single opportunity. A branch to fall. A giant to die. Anything that opens a gap above. When that gap appears, the response is instant. Seedlings surge upward. Vines shoot skyward. Ferns unfurl. Growth that took decades suddenly accelerates in weeks. But most of the time, no gap comes. So plants adapt. Some grow leaves so thin they're nearly transparent. Others grow leaves the size of umbrellas, trading strength for surface area. And some abandon photosynthesis entirely. Strangler figs begin as seeds dropped by birds high in the canopy. Roots snake downward along a host tree's trunk, thickening, fusing, tightening. The fig grows. The host slowly dies, starved of light, trapped inside living wood. Eventually, the original tree rots away, leaving the fig standing alone, hollow and victorious. Other plants skip trees altogether. Pitcher plants hang from branches filled with digestive fluid. Insects fall in, dissolve, and become nutrients. It's faster than waiting for sunlight. Predators wait here too. Jaguars move through shadow without sound. Snakes coil at eye level. Poison dart frogs advertise danger in colors that burn into memory. Nothing is wasted. Every niche is occupied. Every resource is contested. And above this layer, the real city begins. The canopy, the vertical ocean. This is where the forest truly leaves. The canopy isn't a ceiling. It's a volume, a maze of branches, vines, air roots, and epiphytes stretching hundreds of feet in every direction. More than half of all terrestrial species live here. Not on the ground. Not in the soil. Up in the branches. Many never come down. Monkeys spend their entire lives overhead. Frogs breed in water trapped in bromeliads. Snakes glide between trees, flattening their bodies to catch air. For most of human history, this layer was almost impossible to study. Scientists didn't seriously access it until the 1970s. What they found felt unreal. Entire gardens growing on branches. Orchids, mosses, ferns covering every surface. Some trees carry hundreds of pounds of epiphytes. Those plants trap rainwater. In a single bromeliad, tadpoles grow, insects breed, and miniature freshwater ecosystems thrive, suspended 100 feet above the ground. The canopy runs on partnerships. Ants live inside hollow thorns, defending trees with violent precision. Fig trees fruit year-round, feeding dozens of species when nothing else can. Remove the figs, and entire food webs unravel. This layer is also a highway. Monkeys swing. Squirrels leap fatal gaps. Birds navigate using landmarks invisible from below. But danger is constant. Harpy eagles hunt through branches, powerful enough to carry off monkeys and sloths. One rotten limb. One slip. The fall is unforgiving. Life persists here not despite pressure, but because of it. If you're enjoying this climb through the forest, subscribing helps you catch future deep dive episodes like this. Above the chaos of the canopy, the giants rise. The emergent layer, giants alone. Emergent trees stand 200, sometimes 250 feet tall. Their crowns rise above the canopy, fully exposed to sun, wind, and lightning. Up here, there is no protection. Temperatures swing. Winds tear past. Storms strike with full force. These trees survive through scale alone. Massive trunks. Dense wood. Roots spreading wide to anchor against collapse. But even giants fall. When one does, it doesn't fall quietly. It crashes through the canopy, pulling down dozens of trees with it. The impact opens a gap, sometimes half an acre wide. Sunlight floods the forest floor for the first time in decades. And the race begins again. Fast-growing pioneer species surge upward, growing feet per year. They dominate briefly, then die young. Slower, stronger trees replace them. This cycle, destruction, regrowth, replacement, is how rainforests renew themselves. Not gradually. In pulses. Each gap is different. Different light. Different soil. Different winners. That variation is what creates diversity. The connections, one system. Rainforests aren't collections of species. They're systems. Underground, fungal networks link trees together, moving nutrients and chemical signals. When insects attack one tree, nearby trees prepare defenses before the threat arrives. When an old giant begins to die, it releases nutrients into the network, feeding the next generation. Above ground, pollinators, seed dispersers, and predators maintain balance. Remove one piece, and stress ripples outward. You can't save just the trees. You have to save everything that makes the system work.